Rick is designing a circular clarifier for a new wastewater treatment plant to receive 15 million gallons of flow. After conducting a feasibility study, he decides that having two clarifiers will optimize treatment operations. If the clarifier has a radius of 43 feet, and he designs a detention time of 135 minutes, the tank height is most nearly A, 8, B, 16, C, 32, or D, 64. Pause the video and give yourself 5 minutes to complete the problem. Have you finished solving the problem? Let's see if you got the correct answer. When designing wastewater treatment equipment, there's 3 things to keep in mind. Number 1, your flow rate will most likely determine dimensions or process capabilities of the equipment in question. Number 2, the detention time is the theoretical time required for a given amount of water or wastewater to pass through a tank at a given rate of flow. This will be the second factor that determines the specifications of your equipment. Lastly, remember that the volume is equal to the product of the area and length of your equipment, which in this case is the tank. These equations will assist you if you ever need to calculate dimensions of any equipment, as you need to do in this question. So the first thing we need to do is find our flow rate, which the question states is 15 million gallons per day. Other information is using dimensions of feet, so let's convert our flow to cubic feet per day. There's 7.48 gallons in 1 cubic foot, so using this conversion we get a little over 2 million cubic feet per day. Next, let's look at the volume equations and see if we can figure out a way to solve for the tank's height. So with a circular clarifier, we essentially have a cylindrical tank, and the equation for the volume of a cylinder is the product of pi, the tank radius squared, and the height of the tank. Another way to look at this is the area of the circular surface of the tank multiplied by the height. We are missing the height, but let's use the other volume equation we discussed earlier, which is the flow rate multiplied by the detention time. Our flow rate is in units of cubic feet per day, and the detention time is in minutes. So remembering that there's 1,440 minutes in a day, we can convert one of these values so that it shares the same units with the other. Let's convert the flow rate from cubic feet per day to cubic feet per minute. That gives us 1,393 cubic feet per minute, and multiplied by the detention time gives us a volume of 188,055 cubic feet. This is where many people will make their mistake. Remember that Rick is using 2 clarifiers, so only half of this flow will be going to each. So here let's divide this volume by 2, and we get 94,028 cubic feet. We can now set this equal to our initial equation to solve for the tank's height. When we do this, we can solve for H, and we get a height of 16.2 feet, which is closest to B. Join us for episode 9 of 52 PE exam problems in 52 weeks.